Hello everyone, and welcome back to the Fluctus Channel. American airborne history is built around speed, surprise, and the belief that elite soldiers can be delivered where roads, bridges, and ports are inexistent. During World War II, U.S. paratroopers jumped into Normandy before dawn on the 6th of June, 1944. Opening routes for the landings and proving how airborne units could shape a battlefield before the main force arrived. Modern jumps still carry that inheritance, but some environments can be far harsher than the fields of France. In Alaska and the Arctic, paratrooping becomes a fight against cold before the soldier ever reaches the ground. Static line jumping means the parachute deploys automatically after the jumper exits the aircraft, using a line attached inside the plane. It is designed for mass tactical drops, where many soldiers leave quickly at relatively low altitude. In freezing conditions, every step becomes harder. Gloves reduce feeling. Weapons and rucks add weight, wind bites exposed skin, and snow can hide uneven ground. Arctic Pegasus 2014 placed that challenge above the Arctic Circle at Dead Horse, Alaska. The operation began with a heavy cargo drop, pushing equipment out before airborne soldiers followed into the Dead Horse drop zone. The exercise brought together U.S. Preußens, Army Alaska, the 6th Engineer Battalion, the Alaska Army National Guard, Air Mobility Command, and Alaska Pipeline Service. Its purpose was direct: build proficiency in Arctic airborne operations under extreme cold weather conditions. The process starts before the aircraft arrives. Parachute riggers prepare the life-saving system. At Joint Base Elmendorf-Richardson, a rigger from the 241st Quartermaster Company packed T-11 parachutes for soldiers of the 11th Airborne Division. Packing begins with inspection. The canopy is stretched, lines are checked, panels are examined, and damaged areas are identified. The rigger organizes suspension lines, folds fabric in a precise sequence, places the canopy into the deployment bag, sets the closing loops, and secures the pack tray. A careless fold can become a dangerous malfunction, so every movement is deliberate. Once soldiers receive parachutes, they move through Jumpmaster personnel inspection. Helmets, reserve parachutes, lowering lines, weapons cases, gloves, goggles, and rucksacks are checked. In the Arctic, cold weather layers add bulk, but nothing can block the harness, ripcord handle, or reserve. Soldiers rehearse exits, count cadence, check canopy control, and prepare to hit snow, ice, or frozen ground. Cargo drops are equally important. Supplies, sustainment packages, and even small unit support vehicles can be rigged onto platforms or extraction systems and delivered by parachute. During Alaska airborne operations, small unit support vehicles were dropped to support movement across snow and ice. At ICEX 2016, Alaska Air National Guard crews also supported Arctic airdrop operations, showing that polar missions require food, fuel, shelter, communications, and mobility packages, not just people. Cold injuries remain a constant threat. Ice rescue training teaches teams how to respond when someone breaks through frozen water, Rescuers use ropes, flotation devices, ladders, and controlled approaches to reach a victim without becoming one themselves. For paratroopers landing in Arctic terrain, knowing how to move around ice can be as important as knowing how to exit an aircraft. Military freefall training shows another side of airborne skill, where soldiers exit at higher altitudes, maneuver under canopy, and land with smaller teams. Static line remains the method for rapid mass drops, while freefall supports specialized insertion. Both demand discipline, but the Arctic adds a brutal filter. Equipment must open, radios must work, hands must function, and soldiers must assemble quickly before cold slows the entire mission down. The jump is only the beginning of survival. After landing, the first task is accountability. Team leaders confirm who touched down, who was injured, where cargo landed, and which direction leads to the assembly area. Parachutes must be collapsed before wind drags soldiers across ice. Rucksacks are lowered, weapons recovered, skis or snowshoes may be attached, and movement begins before body heat disappears. In temperate terrain, a delay may be inconvenient. In the Arctic, a delay can become life-threatening. That is why the jump, the cargo drop, the rescue training, and the sustainment package belong to one connected system. Airborne mobility only works when soldiers can fight the climate after the parachute is packed properly. Ice exercise, known as ICEX, takes the Arctic problem from the air to the frozen ocean. Navy has operated in polar regions for generations, and under-ice training has grown into a recurring test of submarine readiness, scientific support, and expeditionary logistics. ICEX 2020 took place in the Arctic Ocean off Alaska, using a temporary ice camp called Camp Sea Dragon as the operating base on a moving sheet of sea ice. Building an ice camp begins with finding ice thick and stable enough to support people, shelters, vehicles, communications equipment, generators, and landing areas. Teams survey the surface, mark safe routes, clear snow, establish tents, run power lines, and create work zones. Nothing is permanent. The ice moves, cracks, shifts, and groans under pressure, so the camp must be watched constantly. The logistics are difficult because normal roads do not exist. Personnel and cargo move by aircraft, snow machines, sleds, and other Arctic transport. Every box must be planned because a missing part can stop a mission. Fuel keeps generators running. Heaters keep people alive. Communications connect the camp to submarines, aircraft, and command centers far away. Food, medical equipment, rescue gear, tools, and scientific instruments all have to arrive before the ice camp can function. Dive training at ICEX adds another dangerous layer. Divers prepare for work under ice by checking suits, helmets, air supplies, lines, lights, tools, and emergency signals. They enter through a cut hole, while surface teams control tenders and safety lines. Under ice, a diver cannot simply rise to open water anywhere. The entry hole is the way out, so navigation, communication, and line discipline are essential. Before a submarine surfaces through ice, teams build a tracking grid. Field parties arrive on the ice, measure and mark the surface, and create reference points to help locate the submarine beneath them. The grid allows personnel to follow the boat's position and select an area where the ice may be suitable for surfacing. It is part science, part navigation, and part safety control. ICEX has been described as part of a long Arctic operating tradition that reaches back nearly a century. But the modern exercise is also about future competition. The Arctic is changing as ice conditions shift and northern routes gain strategic attention. Submarines must be able to operate below the ice, communicate through it, surface through it, and receive support from teams living in one of the harshest temporary bases on Earth. Camp Sea Dragon existed to make those skills real. It turned a frozen ocean into a command post, runway, dive site, weather station, and submarine support hub. Every tent stake, fuel drum, radio antenna, and marked trail supported the larger goal, proving that the Navy can work where the map looks empty, but the strategic value is enormous. When the camp closes, the same care runs backward. Equipment is packed, waste is removed, shelters are broken down, and the ice is left as cleanly as possible before teams depart for the season safely. The most dramatic Arctic naval operation is a submarine rising through the ice. Below the surface, a submarine controls depth through ballast tanks, trim, propulsion, and diving planes. To dive, the boat increases weight by taking water into ballast tanks and angles itself downward under control. To surface, it becomes more buoyant by forcing water out with high-pressure air, then uses careful trim and upward movement to reach the surface. Under ice, that process becomes far more complicated. The submarine cannot surface anywhere. The crew must search for ice thin enough or broken enough to penetrate, while avoiding pressure ridges that may be too thick or dangerous. Sonar, charts, upward-looking sensors, and data from field parties help guide the choice. Inside the control room, watch teams track depth, speed, course, ballast status, and the condition above them. A ballistic missile submarine, such as USS Pennsylvania, can sail for long periods while maintaining strategic deterrence, but Arctic training emphasizes careful navigation and undersea control. As the submarine heads toward an exercise area, the crew monitors contacts, verifies systems, controls noise, and moves through the water with precise depth changes. Every movement is planned because the Arctic ceiling is solid. During ICEX 2016, USS Hartford surfaced near Ice Camp Sargo. The process began below the ice, with the boat slowly rising toward a selected point. As the sail pressed upward, ice cracked and lifted around it. The submarine did not burst upward like a movie scene. It forced its way through with controlled power and hull strength. Chunks of ice broke around the sail as the black shape appeared in the white landscape. Inside the control room, the atmosphere is disciplined. Sailors call out readings, watch instruments, and follow orders from the officer of the deck and commanding officer. Depth changes are small and deliberate. Ballast adjustments affect the boat's angle. Too much speed or poor alignment can damage equipment. Too little upward force may leave the submarine trapped beneath ice it cannot break. Once surfaced, the crew still has work to do. Hatches may be cleared by hand. Ice is inspected around the sail. Communications are established, and personnel coordinate with the ice camp. The submarine becomes part of the temporary Arctic base, connected to divers, scientists, aviation teams, and field parties on the surface. Arctic surfacing proves more than engineering strength. It shows that submarines can hide, maneuver, and communicate in a region where surface ships face brutal weather and shifting ice. Together with paratrooper drops, cargo airdrops, ice camp logistics, and rescue training, the surfacing event completes a full Arctic readiness picture. America's forces must arrive by air, survive on ice, work below the frozen ocean, and return safely. In the Arctic, readiness is measured in minutes, heat, bearings, and breathable air under pressure when ordered. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.